So we are now going to be solving motion problems using formulas rather than graphs. All right. I encourage you to look over the linear motion notes from the other sheet, but I prepared another version of that right here. And first of all, a reminder that we have both vector ways of describing motion and scalar ways of describing motion. But both of these methods of describing motions just use the same units and the same variables, okay? Keep that in mind as you're solving these problems, okay? And just to point out that these formulas that are all written here are also on your reference tables. So just to point out, all right, we're going to be using this mechanics page in your reference tables basically through the holidays. And the equations that we're looking at right now for this are these guys right here. Okay, we're going to be using all of these. They're called the kinematics equations. Okay, now, first of all, I want to distinguish between uniform and non-uniform motion. So in uniform motion, we have constant velocity, which means no change in speed or direction, and also zero acceleration. When that happens, you will usually use this formula. And notice this is written a little bit differently on your reference tables. They use a V bar to do average, all right? And if we come over here to look at what this means, all right, V is for velocity and speed, and V bar is the average velocity or average speed. There wasn't an easy way to do this on the document, so I just wrote average here. Okay. Now, if you determine that the object is moving with uniform motion, this is the formula you're going to use. But if it's accelerated motion, this is a very dangerous formula to use. And the reason is that whenever we talk about speed, you have to distinguish between the different kinds of speed, right? Or velocity. So we have average, which on your reference tables is going to be represented with V bar. All right. We have the initial velocity, which is the velocity at the beginning of the problem, and you decide where the beginning of the problem is. The final, which is at the end of the problem, and again, that's when you decide. And then there's change in velocity. All right. All of these are distinctive. And the one that's actually equal to distance over time or displacement over time is average velocity. And so it's very dangerous to use this for accelerated motion because people tend to plug in one of these other velocities in for average, and that doesn't work for accelerated motion. All right. So I'm going to spend some time talking about how to do some uniform problems, and then I'm going to hand off the accelerated motion problems to another video made by another teacher. All right, so we start out with this problem here. Cassie and Owen measure the velocity of a wind-up toy whale by timing the distance it takes to travel 2 meters east. The average time they measure comes to 34.45 seconds. What is the average velocity of the whale? This is a hilarious problem because we have one significant digit here and 4 here, but that's not a priority of this class. So if you don't know what I'm talking about, don't worry. Now, in this method that we showed in the second video that you're going to watch, what we want to do is give you an emotion analysis table, and maybe a little graph would be helpful, right? But here's the key. This is we're looking for the average velocity of the whale, okay? And what do we know? So we have this little motion analysis table, and I'm going to go ahead and complete this, even though this is a uniform motion. So I have VI, VF, DA, and T. All right, what do we know? We know T is 34.45 seconds. All right. And we know that the distance it's going to travel is 2 meters. Okay. And we want to know what the average velocity is. Okay. We don't know what the initial or the final are, but we do know that this is, and we don't really know the acceleration. All right. But because we're looking for average velocity, this is a case where we don't really need all of this stuff. Okay. And as you're going to see in harder problems, you need 3 pieces of data to solve an accelerated motion problem. You do not need that for a uniform motion problem. You really just need 2 formulas, 2 pieces of data, because you only have 3 elements in your formula. So the formula is V equals D over T. We are looking for average velocity. All right, so I'm literally just going to plug this in here. V equals the D, which is 2 meters, all over the time, which is 34.45 seconds. And then I can go ahead and solve this for the average velocity, and you're going to complete that for homework. This problem here, where Hans is yodeling down into the bottom of a canyon, this is a constant speed as well. All right, so this problem here is going to be very similar to number 1. Now, when we get down to 3, 4, and 5, this is where it's going to be critical that you fill in this data table to get all of the data that you need to solve this and pick the right formula. More on that on the next video.